Hey guys, I am Timmy
I am Tani,
and we're going to introduce logarithmic functions.
For today's video, we have three objectives. First is to rewrite exponential equation in logarithmic form. Second, rewrite the logarithmic equation in exponential form. And lastly, evaluate logarithms.
The word logarithm is derived from the word logos and arithmos, a word made up by John Napier. It is the exponent or power to which a base must be raised to yield a given number.
Definition: let A, B, and C be positive, real numbers such that B is not equal to 1. The logarithm of A with base B is then denoted by log A to the base B and is defined as C equal log A to the base B. If and only if A is equal to B raised to the power of C. Reminders: A is equal to B raised to the power of C is equal to C equals log A to the base B. Both the logarithmic and exponential forms, B is the base. In the exponential form, C is the exponent. This implies that the logarithmic is actually an exponent. Hence, logarithmic and exponential functions are inverses. The logarithmic form, log x to the base b, x cannot be negative. The value of log x to the base b can be negative. Common logarithms. Common logarithms are logarithms with base 10. Log x is a short notation for log x to the base 10. And natural logarithms. Natural logarithms are logarithms to the base e, approximately 2.71828, are denoted by ln. In other words, ln x is another way of writing log x to the base e. For example, write exponential equation in logarithmic form. We have 2 to the power of 5 is equal to x. And the logarithmic form is log x to the base 2 is equal to 5. 2 raised to 5 is equal to x. And the logarithm of x with base 2 is equal to 5. Another example is 5 raised to the power of 3 is equal to 125. And the logarithmic form is log 125 to the base 5 is equal to 3. And the other example is 7 raised to negative 2 is equal to 1 over 49. And the logarithmic form is log 1 over 49 to the base 7 is equal to negative 2. Another example is 10 raised to 2 is equal to 100. And the logarithmic form is log 100 is equal to 2. Another one, 2 over 3 squared is equal to 4 over 9. And the logarithmic form is log 4 over 9 to the base 2/3 is equal to 2. Reminder: it's okay if your base is fraction, as long as it is positive. For this one, we have e squared is equal to x, and if we write it in a logarithmic form, we have ln x is equal to 2. It means that our base is e. Try to look at this one. We have negative 2 squared is equal to 4, and it cannot be written in logarithmic form because the base is negative. Write logarithmic equation in exponential form. For example, this one, we have log 64 to the base 2 is equal to 6, and 2 raised to 6 is equal to 64. The logarithm of 64 with base 2 is equal to 6, and 2 raised to 6 is equal to 64. Write each exponential equation in logarithmic form. For example, the logarithmic form, log m is equal to n, and the exponential equation is 10 raised to n is equal to n. If you're wondering where 10 came from, it came from the log m is equal to n. If you don't see any base at logarithmic form, it means 10. Next example, we have log 81 to the base 3 is equal to 4, and the exponential equation is log raised to 4 is equal to 81. We also have log 5 to the base square root of 5 is equal to 2, and the exponential equation is Square root of 5 raised to 2 is equal to 5. Another one, ln 8 is equal to a. The exponential equation is e raised to a is equal to 8. Evaluate the following logarithms. For example, we have log 27 to the base 3. Let x is equal to log 27 to the base 3. So we have 3 raised to x is equal to 27. 3 raised to x is equal to 3 raised to the power of 3. If you're wondering, the base must be similar. Yep. And if you're also wondering if why is it 3 cubed, so 3 cubed is equal to 27. In solving this problem, we only have to get the exponent, which is x is equal to 3, and that was the answer. So, log 27 to the base 3 is equals to 3. Another example, we have log 625 to the base 5, and let x is equal to log 625 to the base 5. We have our base 5 raised to the power of x is equal to 625. We will also do the same as the first example, so we have the same base 5 raised to the power of x is equal to 5 raised to the power of 4. If you're wondering again why 5 raised to the power of 4, it's because 5 to the power of 4 is equal to 625. As I said, we only get the exponent, which is x is equal to 4, and that is the answer. So, log 625 to the base 5 is equal to... Another example, we have log 5 square root of 5 to the base 5, and let x is equal to log 5 square root of 5 to the base 5. So, 5 raised to the power of x is equal to 5 square root of 5. 5x is equal to 5 times 5 raised to the power of 1 half. We have x is equal to 1 plus 1 half. Our answer is x is equal to 3 over 2. Where did we get 3 over 2? So, we have to multiply 2 times 1 is equal to 2, and add by 1 is equal to 3, so we have 3 over 2. So we have here log 5 square root of 5 to the base 5 is equal to 3 over 2. In this example, we have log 0.01, and that x is equal to log 0.01. And since it is common logarithmic, we have 10 raised to the power of x is equal to 0.01. How can we get the base 10 in 0.01? So we have to simply express 10 is raised to the power of negative 2. As I said, we only have to get the exponent, so the answer is x is equal to negative 2. We have log 0.01 is equal to negative 2.
So guys, since it's already late at night, you can see, we're going to end this video now, and we hope you guys learned something new today. Bye bye!